This is Unit 1, Physics Applied Science, and the June 2017 paper, question 13. So we've got some data to work with in a diagram here about satellites around the Earth. One thing to notice on here, well, we've got our visible light region, which is here. So this is our visible light. And we've got radio waves, which is maybe from there to there. So our radio waves are kind of there, and our visible light is there. So those are the two regions of this graph that we're interested in. Another thing on this graph, it's the wrong way around. So in physics they do little tricks on you like this. So you can see the big number is on the left, and they seem to have 0 at the origin and then go to 10 to the 18, but we will ignore that. And then the number gets smaller as you go right. So this is a small number frequency on the right, small frequency, and on the left near the origin is a large frequency. So some of you have got that the wrong way around when reading the graph. So explain the advantages and disadvantages of using radio waves instead of light waves to send large amounts of information from a satellite. So if this doesn't happen, then that asteroid might hit the Earth and there'll be no Bruce Willis to save you.
How do you know?
How do you know? There might be. You're retired by then. So we've got to look at how the first point, there's 4 marks here, and again this is really 2 points with an explanation for each one. That's how you need to sort of design your answer. So I'm going to say the first thing, then give an explanation, then say the second thing and give an explanation. The first thing is aimed at kind of past level of just kind of noticing stuff, and the second thing is kind of the merit and distinction material. So let's look at visible light. We see that here that not all the visible light gets through to the Earth. This graph here at the side is how much is absorbed. So if it's absorbed, it's not getting through. And some of you have got a little bit confused with this. So some visible light gets through, but some is absorbed. So some visible light is absorbed by the atmosphere, and so you're going to lose some information. So we'll lose some information. You could do that the other way around. You could say, look here in the radio waves, some radio waves like these ones here are going to get absorbed, so they're no good, but some here like 10 to the 9, 10 to 8 are going to get through. So you could say some radio waves absorbed, but others not absorbed, so that would be good. And then for the second mark, it's a completely different point regarding the carriage of information. So visible light, because it has a higher frequency, can carry more information. So radio, lower frequency, carries less information. So visible light has higher frequency, and some of you have got this the wrong way around. So that's the mark. So can carry more information. And why would this be useful? Well, this is all about quickly sending information about asteroids hitting the Earth. So could transmit the information in a shorter time. So carry more information and transmit the information in a shorter time. And we'll continue this question in the next video.